Yeah, we solve this number 22, and then yep, tell me problem you wanna look at. Okay, okay, all three number problems. Yep, so let's see number 23. Let me first copy this. Yep, so there are five types of transformation in this case. The three transformations are rotations, and two transformations are reflection. So uh, if we use one of the reflections, we need to the reflections, I mean, uh, together to make it the triangle back to the original position. So let me show you an example. When there is a triangle, oops. If we make the horizontal reflection means this way, and then we are going to make the a vertical reflection. Vertical reflection makes this one, and going back to the original position, we need to make this 180-degree rotation. So that's one type of transformation to make the triangle back to the original. So horizontal, vertical, and 180-degree rotation. Let's say that's R2, or the second rotation. And in this case, the order uh, order is not important. If we take any type of order, it will make the triangle back to the original. So that means we can make a six number of cases using these three factorial. And if we don't use reflection, if we use only these rotations, the rotation should be the multiple of 360 degrees to make the triangle go back to the original. So one example is 90 degree two times and 180 degree, and they make the sum of the angle 360 degrees. And in this case, because two rotations are the same, we need to divide 3 factorial by 2 factorial. So the number of cases is 3. And if we use this 270 degree counterclock rotation, actually that's the same as 90 degree clockwise rotation. So we can say this is the same as minus 90 degree because the direction is negative. This means if we use this, let's say this rotation R3, if we use our rotation R3 twice, that makes minus 180 degree. And then when we use this R2, we negate this minus to the 0. So that's why the triangle stays in the original position. And once again, because these two things are the same, 3 factorial divided by 2 factorial is 3. And so these are the types of transformation. So how many number of cases are possible? 12. Yeah, so the answer is A. Actually, the triangle looks like this instead of this. But I mean, principle is the same. Yeah. And in number 24, in this case, uh, it's good to know use uh, this property. If this G means the greatest common factor, in this case, greatest common denominator, it's the same as this one. So when we add these two numbers, the GCF doesn't change, and that's the property. So I'm going to use this property to solve this problem. So for the first one, when we add 63 and 120, the GCF doesn't change. So the sum of 63 and 120 is 183, and still the GCF is 21. For the second case, once again, we can add 63 and 120. And in this case, the GCF is 60. So by doing this, now we have the common number, the n plus 183, and this number should be the a common multiple of 21 and 60. So can you think of the common multiple, least common multiple of 21 and 60? Yep. Now which number can you use to divide both the numbers? 3. Yeah, that's it. And then when you multiply all these three numbers, the LCM of 21 and 60 is, yeah, multiply these three numbers. Yeah, 420, right? 21 times 20. So that means this n plus 183 is a multiple of 420. And because the number is greater than 10, we can start with uh, yeah, 420 times 3. That's 1,260. And if we use this number, in this case, the GCF between 63 and 1,260 is 63 instead of 21. So this is not the case we want. And what's the next multiple of 420 after 1,260? So that means you are multiplying 4 to 420. Watch this product. Yeah, 1680. And if we use this number, if we check this GCF, the GCF between this number and 120 is 120 because this 1680 is a multiple of 120, so it's not 60. So this is also not the case we want. And how about what's the next multiple of 420? Can 2100, and in this case now GCF between 63 and 2100 is 21, and GCF between 2100 and 120 is 60. So now this is the number we want, and that's equal to n plus 183. So now what's the value of n? Yeah, 17. And then finally, what's the sum of the digits in 1917? Yeah, when you add these four numbers, 28. Oh, it's 18. Uh, am I right? 10 plus 8. Yeah, 18. Yeah. Okay. Yeah. So that's alright. Yep. So the answer is C. And in number 25, let's see. At first, let's first find out the probability for having number 7 from 3 dice. So if we one example is like this, now the sum of these three numbers is 7 from these 3 dice, and if we keep number 1 here, we have 5 cases if we include number 1 in the first die. And if the first die has number 2, to make the sum of 7, this will be the second triple. So what I can say is, if the first case is 5, the second case is 4, so it will keep decreasing as the number in the first die is increasing. So we can make the sum of 5 through 1. So yeah, what's the sum of these 5 numbers? Yeah, 15. And so there are 15 cases to make the sum of 7 from 3 dice, and the total case is the 6 cube. So for the probability, it's like 15 over 6 cube, 216. That's equal to 5 over 72. And in this problem, we want to throw the 2 of the dice. So that means he will throw 2 of the dice if the probability is greater than this one. If the probability is less than this 5 or 72, he will throw 3 dice instead of 2. So that's one requirement. Or he can throw just 1 die instead of 2 dice if throwing 1 die has a higher probability of making sum of 7. And such case means let's use this example. Let's say this way. Let's say the first trial make these 3 numbers, and in this case to make the sum of 7, he will change this. He will throw this one die again, and if we make number one, now the sum is 7. So that's one of his strategy. So in this case, he needs to have number one from on the second trial by throwing one dice, and the probability is 1/6, and or this way. Let's say the sum comes out this way, and then to change this, he can change this number to, for example, 3. And so what I want to say is, if he throw just one die, the probability is always 1/6, because any number from the dice has the same probability, 1/6. And this case means when the first trial, if sum of the two numbers is less than 7, to fill up the remaining gap, she can use throwing one die instead of two. And throwing one die, the probability is always greater than the throwing two dice, because when you think of this example, throwing two die starts from 5 over 36. That's the maximum probability if we use two dice. But because throwing one die has the probability 1/6, that's always greater than throwing two dice. So this means to decide to throw two dice, the sum of the two dice should be greater than or equal to 7. If it's less than 7, he will just throw one die instead of choosing two dice. So let's think of the case. So if any number in the dice is 1, the second die should be at least 6, because the sum should be greater than or equal to 7 if we choose to throw two dice. So this is a kind of example. In this case, he will throw these two dice to make the sum of 6, and to make 1 plus 6 7, and to make the sum of 6 out of two dice is this 5 over 36, and this probability is greater than 5 over 72. So he will choose throwing two dice instead of throwing all the three dice again. And let's say the first number is 2. So once again, if the triple looks like this, he will throw these two die to make the sum of 5, and making sum of 5 out of two dice is this one, the 4 over 36. Still, this 4 over 36 is greater than 5 over 72. So he will choose to throw two dice instead of throwing three dice. And we can think of other triples in the case when the first number is 2. So in this case, again, because 2 plus 5 is still greater than or equal to 7, he will throw two dice instead of throwing one die or three dice. or uh, this this case too, still the sum of the two dice is uh, greater than or equal to 7, so he will choose throw 2 die. And if the first number is 3, like this, now he will throw these 2 die to make the sum of 4, and making a sum of 4 out of 2 dice is 3 over 36. And still, this is greater than 5 over 72, so he will choose to throw 2 dice. And we can think of other cases when the first number is 3. Yep, there are many cases because the 3 plus 4 is still greater than or equal to 7. So, yep, so now we have all the cases, and then we need to think of the arrangement. If two numbers are the same out of 3, the number of arrangement is 3 because 3 factorial divided by 2 factorial is 3. This one too. And when all the numbers are different, the number of arrangement is 6. And then we need to find the sum of these numbers. Sum of these 4 numbers is 15. Sum of these numbers the is 27. So the final sum is 15. Yeah, 15 plus 27 is 15 plus 27. Yep. 42, and then the total case is 216, the 6 cube. Can you simplify this fraction? Yep, I mean the common GCF is, you can divide by 6, right? Yep. Mm-hmm. Yep. So the answer is A. And then, yeah, let's move to next section.